This is part of the KTA Lunch and Learn series. This one is paint removal from masonry substrates. My name is Ken Trimber. I'm your presenter. I have over 45 years of coating inspection and testing experience. I've got SSPC and NACE certifications. I'm the president of KTA and responsible for overseeing our technical services and deliverables. With regard to this specific subject, I'm the chairman of the SSPC Surface Preparation Committee and also the chairman of the SSPC Commercial Coating Committee that has task groups on cleaning and painting of commercial buildings, coating materials for commercial buildings, flooring, air barriers, and contractor certification and training programs. The learning objectives of this Lunch and Learn are to identify the SSPC, NACE, ASTM, and ICRI standards and guidelines that apply to the removal of paint from CMU. I'm also going to describe the various methods of paint removal, including the advantages and disadvantages of each. Before you decide what type of preparation, surface preparation to use, ask these questions during the design stage. These questions can very much help you decide what should be used for the project. Does all the coating have to be removed or just the loose coating? If all the coating must be removed, can small amounts still be permitted to remain in the porosity of the block, or does everything have to come off? Can roughening of the surface be tolerated, and if so, can it be heavy or only slight roughening? Can large volumes of water be tolerated, both from terms of an environmental standpoint as well as potential water intrusion into the substrate? And finally, can airborne dust be tolerated? So we're going to go over some of the industry standards and guides and show you photos of the different methods of removal to help answer those questions. The standards we'll be discussing briefly are SSPC 13 or NACE 6, which is surface preparation of concrete. That standard has a number of different methods of concrete preparation all housed in one document. ICRI guideline 3010-2 for selecting and specifying concrete surface preparation for sealers, coatings, and polymer overlays. The ICRI document also has a series of surface profile coupons that are available. You see they go from very smooth on the left to much more rougher on the right, depending on the method of removal. It's a good way of judging whether or not the roughness being required by the methods has been achieved. ASTM standards, there are 4 of them. D4258 for surface cleaning of concrete for coating, and this addresses all the different mechanical methods that I'll be talking about. And abrading concrete 4259. 4260 is for acid etching of concrete for floors, and 4261 is just surface cleaning of CMU. What I've done is categorize the different paint removal methods or preparation methods and showing the standards that apply to it or have something related to that subject. So dry abrasive blast cleaning, for example, it's covered in the SSPC standard, the ICRI, and ASTM D4259. Water cleaning and water jetting are covered in the same 3 standards. Wet abrasive blast cleaning, though, is only covered by SSPC and ASTM D4259. It is not addressed in the ICRI guideline. Impact power tool cleaning, go back to the same 3 standards, SSPC, ICRI, and ASTM. Same with power grinding and sanding. All 3 of them address that subject. Scarifying, grinding, scabbling, and milling, much more aggressive methods of preparation, are only addressed in the ICRI guideline and ASTM D4259. For acid etching, we have the same SSPC and ICRI guidelines, but ASTM changes. It's ASTM D4260. For flame cleaning, it's not addressed in ASTM, only SSPC and the ICRI guideline address it. For detergent cleaning, again, SSPC and ICRI address it, but for ASTM, it's 2 different methods, 4258 and 4261. For air blast cleaning, water cleaning, steam cleaning, vacuum cleaning, methods for cleaning the surface of the masonry, you've got the SSPC standard and ASTM D4258, 4261. It's not covered in ICRI. Chemical stripping. This is an effective method of paint removal, but it's not addressed in any of the standards or guides mentioned above. So here are the methods I'm going to briefly discuss. dry blasting, wet blasting, sodium bicarb blasting, which is kind of a variation of wet blasting, water cleaning, low pressure and high pressure, both being below 10,000 psi, high temperature pressure water cleaning. Now we're adding a temperature to the water, elevated temperature, and that's less than 5,000 psi. Water jetting, which is as high as 30,000 psi or more, power tool cleaning, and chemical stripping. For dry abrasive blast cleaning, here we're propelling abrasives against the surface using compressed air. The abrasive, if you don't turn it down, can be as much as 400 miles an hour or so coming out of the nozzle. So you can imagine what kind of damage that can do if you're not very careful in adjusting your pressures and work distances and so forth, how much damage that can do to a masonry substrate. Different types of abrasives are used depending on what you're removing or how aggressive or non-aggressive you want to be. And it is a very dusty operation. It may require some containment. I mentioned the fear of roughening it. Here's an example of CMU block abrasive blast cleaning. You still have large amounts of paint remaining and very chewed up block. So it's difficult to selectively remove loose coating with this method because it can really tear up the block and you can tear up the mortar joints as well. Elastomeric coatings can be difficult to remove due to bounce back of the abrasive. As a result, by the time you, quote, burn through the coating, you may really tear up the block. Here's another example of damaged block. Here you see the block was very soft on the left, the mortar joint much harder. The mortar joint was not affected by the blast cleaning, but the block certainly was. And on the right you can see that one area is 1/8 of an inch, and in some cases deeper, in terms of the damage created. So if you're going to dry blast, make sure you do a test area first to make sure you're okay with the final appearance before you do this on a wholesale job. Another method of dry blast cleaning are centrifugal wheel units used for floors. In this case, you've got a wheel that spins inside the unit and throws the abrasive to the surface, and it's vacuumed at the same time, cleaned, and then recycled and reused. Very common for cleaning floors. Wet abrasive blast cleaning. This is a variation of dry blasting in that you mix water with the abrasive to keep the dust down. You still have the same potential though for roughening of the surface. Expendable abrasive is used, it's not recycled, and you either have a water collar, which is what you see here. That top black hose carries a small amount of water into the collar that creates a cone of water around the abrasive that comes out the blast nozzle, which is the large diameter black piece that you see in the picture. Others have special nozzles where the water is mixed prior to the abrasive exiting the nozzle to create a bit of a slurry. And other is special equipment that creates a slurry that's pumped through the entire blast hose rather than mixing the water at the nozzle. And here's an example of one of those methods called vapor blasting. A low volume of water is used and you're now pumping a slurry through the hose, so it's a well-wetted abrasive. And you look at this, there's no dust being created. What you're seeing there is kind of a mist of water, but it does excellent control of dusting. You do have damp abrasive to clean up, but it's sort of like beach sand. There's not large volumes of water laying around at all. And it's a very nice method to use. You can very well control the cleaning with this method. You can see very well, really essentially no dusting. Sodium bicarbonate blasting is another variation of wet blasting. In this case, you're using baking soda, which is water soluble. Now, it's a larger size than household baking soda, but does a very good job of cleaning the surface. The baking soda is added right at the nozzle, so it doesn't dissolve by the time it hits the surface. And yet, when you're done, you have no abrasive to get rid of. It's just solubilized sodium bicarbonate and water. There you see some line deposits or efflorescence coming out of some integrally colored block on the top, and the bottom it was cleaned with sodium bicarbonate. But notice the risk here. While you did remove the deposits, you've taken some of the color out of the block. So again, do a test area for any of these methods to make sure that the end result is okay, that you're not creating other problems by trying to remove surface contamination or graffiti. But it can do a very effective job of cleaning, but in this case, because it was integrally colored, it actually took some of the color out of the block, which was not acceptable. Now I want to talk about water cleaning, both low pressure at less than 5,000 psi and high pressure, which is 5 to 10,000 psi. Water cleaning is very common on buildings. It effectively removes your loose coating and surface contamination. The 0-degree tip that spins does an excellent job of improving efficiency. And it can remove all coating if you really dwell on it long enough, but that creates other problems with saturation of the substrate with moisture, which you really don't want. But generally, you're using 5 to 10 gallons of water per minute, so it can be quite a large volume of water is used. But here's an example of pore cleaning. Now, it's supposed that this tip was not spinning. You can see the streaky patterns of like a 0-degree tip, but it wasn't spinning. So right off the bat, we've got some problems. But whenever you're washing the surface, just like washing your car, when the surface gets totally wet, it's difficult to see whether or not you removed the contamination or hit every square inch of the surface. And in this case, you can see the very erratic, streaky pattern where the nozzle hit, good removal. You got the removal of the contaminants. But everywhere adjacent to it, you still have all the surface dirt, dust, chalking, debris remaining on the surface. So it's very, very operator dependent, and you have to have the right equipment and operating properly to do a good job of water cleaning. Another drawback from these lower pressure units, because they use so much water, if you try to remove the total coating, which was done on the outside of this block, you're now looking on the inside, the dwell time required to remove the coating on the outside really just saturated the blocks on the inside. So now we have walls that are soaked, that have to dry out a lot before putting the exterior coating on. And if this has core fill insulation in it, now we've saturated the insulation. So be very careful about the dwell time when using these water methods. So you, again, don't create other problems by trying to prepare the surface on one side of the block in this case. Another variation that is pretty effective is high temperature, low pressure cleaning. We're still at less than 5,000 psi. You're seeing a fan tip here. But in this case, we've got 250-degree water temperature. It really improves the removal of the coating and the efficiency. You can see it basically softens this particular coating. You can tell by the edges how it softened it to help remove the total coating in this case. So that's another option, is high temperature, low pressure. Usually maximum 250 degrees is used. Water jetting. Now we're increasing the water pressure. High pressure water jetting is 10 to 30,000 psi. Ultra high pressure is more than 30,000 psi. It's less water than low volume units, and it efficiently removes coating. And one nice thing with it, there are some units that have an integral vacuum system that actually collects the water while it's being used. So you see there's not a lot of water flying around here for cleanup. It's collecting it for disposal while the cleaning is underway. And here's an example of some water jetting. You see on the top the coating is removed, but that again has a very roughened texture to that smooth block. So someone's going to have to decide if that texture is acceptable. Another problem you have, and here we're doing the full wall on the right, you'll see split face block and smooth block being done, as well as scored block in the middle. But if the blocks are different hardness, or they're not exactly in the same plane, in other words, one block sticks out a little bit more than another, the water jetting distance will be different, and you can actually damage the blocks that stick out a little more than the blocks that are further away from the jets, and get some erratic cleaning and cutting of the blocks. So again, test areas are necessary first before trying this to make sure it's the right candidate for the job. But with the vacuum and the really lower volume of water, you don't get as much saturation of the block with this as you do with some of the other water methods. Now, power tool cleaning. Power tool cleaning is sanding, grinding, needle gunning, rotopening. The sanding will do much less damage to the substrate while removing the paint. And again, similar to the water jetting, vacuum shrouds are available to really reduce dust, capture the material at the point of generation. The power tool cleaning, though, is best used for localized removal. It's hard to do a large surface with power tools, very inefficient, but the sanding is very good for feathering. Here you see some coating that was removed and feathered back to make a smooth transition between the removed coating and the original surface. Okay, chemical stripping. Chemical stripping effectively removes all of the existing coating. Chemical stripping is another method of coating removal, and in this case it removes all the coating. There are also biodegradable strippers available that don't contain methylene, chloride, or caustic material, so they're more environmentally and worker safe. In order to use the stripper, you first apply it to the surface, brush, roller, or spray, and really you should do a test pass to see how many applications are needed, what the dwell times are. But typically you allow it to set overnight, and then remove it by scraping, bucket and sponge, or pressure washing. In this case, you can see that not quite half the coating was removed by the first application, so a second application was used. And it's often necessary, but again, your test patch will tell you that. So here you have the second application being applied, then it's followed by removal. And in these examples, you can see that the second application was plenty good enough because essentially all the coating has been removed. And the water, of course, has to be collected for disposal, but it is an effective means of non-evasive removal of paint without damaging the substrate. Puts no texture on the substrate at all. So let me get back to the original project design questions. Is all the coating have to be removed or just loose coating? You can see from the methods we went over why that's an important question. If all that must be removed, can small amounts be permitted to remain? Again, an important question. Can roughening of the block or brick or substrate be tolerated? If so, can it be heavy or only slight? Can large volumes of water be tolerated, both environmentally, in terms of water saturation of the substrate, and can you tolerate airborne dust? So let's look at the methods. All right, so now let's look at all of the methods of removal as they relate to those questions. The questions are shown across the top, and I'm going to go over these each individually. So we'll do it a section at a time with the removal methods down the left. So let's go to the first one. The first one is the extent of coating removal feasible. For dry blasting and wet, you're taking all the coating off essentially. While you can do some selective removal, it's really when you want to take essentially all the coating off, you would use it. Partial removal would be the sodium bicarb and the lower pressure water. The high temperature water could also be used reasonably effectively for total coating removal as well as partial removal. Same with water jetting, meaning if you move quickly enough, you can either do partial or total removal. Power tool cleaning is essentially partial removal. It's really not practical to do all coating removal with power tools. And chemical stripping, it's essentially total removal. Once you start it, you want to take all the coating off. Next question, what about the roughening? Dry blasting and wet, definitely heavy roughening, and it can be extremely heavy. So you need to check that out in advance before you start to use it. Bicarb and all the water methods, really essentially slight to no roughening, except when we get to water jetting. When we get to water jetting, as you saw from the examples I showed you, you can get some pretty heavy roughening with water jetting. Power tool cleaning, you can control it with sanding to have no roughening. If you go to scabbling methods or impact tools, you will definitely have roughening. Chemical stripping basically doesn't distort the substrate at all in masonry. It won't roughen it. Now what about the paint residue and the porosity of the substrate? Dry, wet, and sodium bicarbonate and pressure washing will definitely leave paint in the porosity because by the time you really dwell on it to remove it out, you're going to chew up the block very badly with the abrasive methods, and with the water you're going to really saturate that block or substrate by trying to get every remnant of paint out of the porosity. When we get to the high temperature water, you can control that a little better. You can use a little less water and get it so there's just a slight amount left. Same with water jetting. You can control that so that there's a slight amount left. Although again, be careful you don't roughen it too much. Power tool cleaning, you really can't get the coating out of the porosity without really damaging the surface. Chemical stripping, though, you can remove it. Okay, now let's look at the volume of water used. Dry blasting doesn't use any. Wet blasting uses a moderate amount, as you saw from that vapor blast. It's just like beach sand. You can really cut it down so there's not much water used. Sodium bicarbonate, low pressure water, and high temperature low pressure water, the next three, have reasonably large amounts of water. Water jetting can be low amounts, although it could be large amounts, depending on the dwell time required, but it does have less water than some of the other water methods when used properly. Power tool doesn't use water. And chemical stripping, depending on the method of removal, will dictate how much water is used. If you use a bucket and sponge, basically there's very little. But if you're doing a lot of pressure washing and multiple applications, you can end up using a large volume of water. Quantity of airborne dust, dry blasting has a lot. Wet is little. Bicarb is basically none. Pressure water, all the water methods are none. Power tool cleaning is little, depending on the method used and whether or not you use vacuums. And chemical stripping really doesn't really have anything in the way of airborne dust. So here's that table again. So it's a pretty decent summary to show you how you might assist you in selecting the method of removal you want for a given project. If you're interested in productivity, you can find some information in the PDCA estimating guide and the ICRI guideline. And finally, this last picture shows water jetting. See how the jets were spinning in that surface? This is one of the vacuum shrouded ones. And you see how it swirls to remove the coating. Well, you can also see how badly chewed up that block is. So if you're going to use it, do test areas first to make sure you don't do unacceptable damage to the substrate in using the water. So please look at the KTA for other topics in this Lunch and Learn series. If you have any questions, you can reach us at www.kta.com or you can contact me directly. And thank you.